Welcome to another episode of Daily AI Brief, your go-to source for the latest in AI technology and innovation. Today, we dive into groundbreaking advancements from major tech players like Google, NVIDIA, and Amazon, discuss funding successes, and explore strategic AI methodologies. Buckle up for segments tailored to help you stay informed and ahead of the curve. Polling servers for updates may soon be a thing of the past, thanks to Google's introduction of event-driven webhooks to the Gemini API. This fundamental change transforms how developers manage long-running AI tasks by eliminating the cumbersome and resource-intensive process of server polling. Historically, polling has been the conventional method for monitoring task completions, but comes with significant drawbacks, such as increased latency and resource consumption. Polling requires continuous querying of servers to check if a task is complete, which can significantly delay workflows and exhaust server resources. By adopting an event-driven model, Google simplifies these processes vastly. Key features. Google's new approach involves 1. Real-time HTTP post notifications. These replace the traditional polling mechanism. As soon as an AI task completes, a notification is sent directly to the developer's application, allowing for immediate action. 2. Enhanced security and reliability. Security is a primary concern. Google's integration of HMAC SHA-56 signing ensures that each webhook is authentic and secure against unauthorized access. Furthermore, automatic retries add to the system's robustness, retrying failed notifications for up to 24 hours, thus assuring message delivery under various network conditions. 3. Idempotency standards. These standards ensure that even if a notification is accidentally sent multiple times, it can be processed more than once without different outcomes, protecting against replay attacks and ensuring consistent system behavior. 4. Asynchronous processing model compatibility. This is particularly critical for AI applications, which often involve complex, long-running jobs that benefit from non-blocking processing workflows. This compatibility enhances the performance and scalability of AI applications, allowing them to handle more tasks simultaneously without a direct increase in resource usage. Performance and efficiency gains. One of the significant advantages of using webhooks is the reduction in latency and overall cost efficiency. By moving to a push-based model, these webhooks lessen unnecessary server queries, thus optimizing resource consumption and cutting down on operational costs. As systems no longer need to repeatedly check for task status, network traffic decreases and application scalability improves significantly. Considerations and challenges. While the benefits are abundant, there are also considerations to keep in mind. For instance, concerns regarding system reliability under heavy loads are common, especially in environments where numerous AI tasks are processed simultaneously. Moreover, adapting existing workflows to accommodate event-driven webhooks might prove challenging, particularly for developers maintaining legacy systems. Getting started. For developers eager to explore these enhancements, the first step is to access the Gemini API through Google Cloud and integrate these webhooks into existing AI workflows. Comprehensive implementation details are available on the Google blog, blash.google/innovationa/technologies, developers event-driven webhooks/OpenA. Broader implications. Google's pivot towards event-driven architectures might not only optimize their own systems, but also set a precedent across the tech industry, encouraging other API and service developers to adopt similar models. By improving task response times and system efficiency, these webhooks could potentially influence how AI applications are architected on a global scale, bringing about a new era of AI task management. ZYG has successfully secured $60 million in Series A funding, aiming to disrupt the fragmented e-commerce landscape with an AI-driven operating system. Led by Excel, this funding round saw participation from major investors like Felix Capital and Lightspeed Venture Partners, pushing ZYG's valuation to $500 million. Building on the momentum from their $58 million seed round earlier in 2026, ZYG has now raised $118 million in total to fuel its vision for a unified e-commerce platform. ZYG's platform aims to streamline operations significantly, addressing the inefficiencies found in traditional e-commerce systems that rely on a patchwork of tools. The company's AI-driven operating system is designed to handle various tasks from product discovery to logistics by using an agentic system. This system automates critical processes such as identifying promising product opportunities and evaluating growth potential in real time. Additionally, it coordinates customer acquisition and retention strategies efficiently, which can optimize costs and enhance user engagement drastically. The platform's data infrastructure is a key element, providing the robustness needed for scalability and ensuring performance that can handle extensive e-commerce operations. While ZIG hasn't fully disclosed performance benchmarks, the substantial funding backing and ambitious strategic goals suggest significant potential for impact. However, moving from concept to real-world implementation poses challenges. The success of ZIG hinges on market adoption, which may require businesses to migrate from their existing fragmented systems to ZIG's cohesive platform. This transition involves risks, considering the deeply rooted nature of traditional solutions and the competition they present. Established e-commerce platforms already offer partial solutions, so ZIG's ability to demonstrate superior reliability and scalability will be crucial. For those interested in ZIG's development, exploring their website may offer insights into their product features and upcoming launches. Investors and business leaders can also benefit from following ZIG's updates on their blogs or social media channels. In conclusion, ZIG's proposed integrated approach could revolutionize e-commerce by streamlining multiple operations into a single, efficient platform. This potential to reduce complexity for direct-to-consumer brands is significant, making ZIG a company to watch closely as they strive to redefine e-commerce management. Amazon's latest enhancement to the Bedrock Agent Core browser lets AI agents break free from browser constraints, enabling direct interaction with operating systems. Launched recently, OS-level actions introduce a new dimension to AI agent capabilities within Amazon's ecosystem. This feature allows agents to perform tasks like executing mouse clicks, keyboard inputs, and capturing screen activities, critical operations that the Chrome DevTools protocol originally struggled to handle. Key components and capabilities. The integration of OS-level actions involves multiple components and capabilities essential for seamless operation. Agent Core Browser and Invoke Browser API. These are at the core of the feature, facilitating the direct control of OS tasks. They allow developers to extend beyond basic web-based automation, integrating tasks that demand OS-level interactions. Mouse and keyboard simulation. Agents can now simulate physical interactions, crucial for automating tasks that require user input. This includes not only executing predefined sequences like form filling, but also adaptive inputs based on real-time data. Desktop screenshot capture. The ability to capture full desktop screenshots empowers agents to monitor, verify, and react to visual information within the OS environment, which is particularly beneficial in quality control processes. Real-time policy control. Security remains paramount. The policy control mechanism embedded within the Agent Core browser actively inspects agent behaviors and prevents malicious activities, ensuring that all actions are authorized and safe. Practical applications and improvements. While exact metrics on speed improvements aren't disclosed, these capabilities are tailored towards complex workflows, particularly those found in enterprise environments where integration with existing systems is crucial. This advancement suggests a significant impact, potentially reducing the time and resources needed for tasks that previously required manual intervention. For developers interested in utilizing these new features, exploring documentation on the Invoke Browser API docs.aws.amazon.com/bedrock-agent-core/latest/bride-browser-invoke-source-OpenAI is recommended. Additionally, the Agent Core FAQ katos.aws.amazon.com/bedrocks agent core/fakes-tdm-source-OpenAI provides setup assistance, and the troubleshooting guide offers solutions to common issues. Security and limitations. Despite these advances, security and potential misuse pose concerns. While policy controls are designed to mitigate risks, the actual effectiveness in diverse environments requires careful consideration. Additionally, the action's customization might be restricted to a predefined set, limiting flexibility in certain situations. Future implications and enterprise value. By bridging gaps between web-based and OS-specific tasks, Amazon paves the way for more sophisticated automation systems. This evolution is particularly valuable for enterprises managing complex, high-stakes workflows across various industries such as finance, healthcare, and logistics. Such organizations may benefit greatly from reduced operational bottlenecks and enhanced task efficiency. Overall, this functionality potentially revolutionizes automation, encouraging enterprises to explore more complex use cases that harness the power of AI-driven automation intertwined with direct OS interactions. While setting a new standard, it also spurs potential development of new application types designed to leverage these capabilities fully. NVIDIA is tackling the complexities of evolving AI systems with its innovative extreme co-design approach, uniquely addressing the challenges presented by advanced agentic systems. Unlike traditional chatbots, these systems manage context dynamically, interact with various tools, and create subagents, leading to highly variable token consumption patterns. In one revealing instance, a session using Claude Code saw token use spike dramatically from 15K to 156K tokens across 283 inference requests, highlighting the need for more robust infrastructure. NVIDIA's strategic solution is encapsulated in the Vera Rubin NVL72 platform, explicitly designed to handle the substantial token demands of agentic AI. Key features include trillion parameter scale. The platform supports trillion parameter mixture of experts, MO, models. This scalability is crucial for handling the intricate operations of agentic systems, allowing for nuanced interaction management and decision-making capabilities. Token throughput. Achieving over 400 tokens per second per user, this platform sets a new benchmark in data handling efficiency. It's tailored to meet the high-throughput demands of agentic applications, reducing latency and improving user experience. Hardware optimization. Multiple specialized chips collaboratively function to optimize performance and enhance energy efficiency. These chips are finely tuned to agentic workloads, ensuring seamless operation even under heavy loads. Despite the promising metrics, there are notable challenges. Token consumption can exceed standard usage by a factor of 15, potentially leading to elevated operational costs. Furthermore, integrating this advanced technology with existing infrastructures may present hurdles for enterprises. For practitioners interested in exploring this cutting-edge technology, NVIDIA's official resources offer deep dives into the Vera Rubin platform. The Grok 3 LPX offers a practical route for addressing low-latency demands in agentic AI applications. Additionally, reviewing NVIDIA's extreme co-design principles can provide valuable insights into modern AI infrastructure. This approach signifies a pivotal advancement towards making agentic systems economically viable at scale. By aligning hardware and software innovations, NVIDIA aims to redefine industry standards, offering a glimpse into a future where high-demand AI tasks are handled efficiently and cost-effectively. The tech world is abuzz with the comparison between vibe coding and spec-driven development, two contrasting methodologies shaping AI development. As developers increasingly rely on AI-assisted tools, understanding these methods' strengths and weaknesses has become crucial. Vibe coding. This approach is celebrated for its rapid prototyping capabilities, allowing developers to explore ideas interactively. Vibe coding is characterized by informal, conversational interactions with AI, using natural language prompts to generate and refine outputs iteratively. It offers unique flexibility, enabling developers to create and test new features or concepts swiftly. However, while vibe coding allows for quick exploration, it often results in significant technical debt, particularly after about 3 months of practice. This debt emerges as undocumented code changes, lack of formal versioning, and potential inconsistencies, the result of a focus on speed over structure. Over time, these issues can severely challenge long-term project viability by complicating maintenance and scalability. API usage in vibe coding, though innovative, can lead to ambiguity without clear guidelines, making it unsuitable for projects requiring strict adherence to predefined requirements. Spec-driven development. On the other hand, spec-driven development offers a more structured approach. Before any coding begins, developers create explicit specifications that outline requirements and expected software behavior. This practice helps mitigate risks associated with requirement drift, where the project's needs evolve without corresponding updates in the development plan. It ensures codes are documented, consistent, and easier to maintain, providing a robust foundation for project scaling. However, spec-driven development can slow down initial development phases due to its rigorous planning requirements. This deliberate approach is often invaluable for preventing bugs and reducing rework, but may limit the agility necessary for explorative stages typical in early development. Hybrid approach. Given the distinct advantages of both methodologies, the analysis suggests a hybrid approach. Developers are encouraged to begin with vibe coding to harness innovation and speed during the project's initial phase. Then, as the need for stability and scaling grows, transitioning into spec-driven practices is beneficial. This ensures that projects evolve into production-ready applications without sacrificing quality for speed. Practical steps. To practically adopt this hybrid model, developers could start by prototyping a simple application using chat-based AI tools typical of vibe coding. Once the application reaches a certain complexity, transitioning into creating formal specifications can aid in scaling and maintaining the codebase effectively. Leveraging continuous integration and delivery practices, which are compatible with spec-driven development, can also maintain software quality and enhance project reliability. Thus, by selectively adopting aspects of both methodologies, developers can innovate rapidly while ensuring their project's long-term sustainability. This balanced approach addresses vibe coding's speed with the durability of spec-driven strategies, aligning the creative process with strategic foresight, especially as the tech landscape becomes increasingly driven by AI-assisted tools. NVIDIA has introduced the cuOpt agent, a groundbreaking solution developed to streamline supply chain decision-making through the integration of large language models, LLMs, with GPU-accelerated solvers. This innovation is pivotal in navigating the complexities of today's logistics landscape, characterized by volatile market conditions and increasing demand for efficiency. A core feature of the cuOpt agent is its ability to handle optimization tasks in real time at an unparalleled scale. This capability is vital for enterprises aiming to maintain a competitive advantage in supply chain management. By leveraging AI, cuOpt enables the transformation of natural language problems into optimized, actionable solutions, ensuring that decisions are both efficient and informed. To implement cuOpt effectively, users begin by setting up NVIDIA GPU environments. This setup ensures that the computational demands of optimization tasks are met with the requisite speed and precision. Following this, the Minimax M2.5 reasoning agent is initialized for optimization tasks. By incorporating domain-specific data, the system generates targeted solutions, allowing for customization across diverse industry needs, from transportation logistics to quick-service restaurants. The process progresses with the invocation of cuOpt skills through LangChain deep agents. These agents facilitate the systematic retrieval of optimization results, which are then executed on GPUs for maximum efficiency. This is where the real power of GPU acceleration comes into play, significantly reducing computational workload and improving the speed of decision-making processes. One of the critical challenges addressed by cuOpt is the rapid and effective integration of LLMs with optimization tools. This integration not only aims to enhance computational efficiency, but also promises substantial cost reductions in logistics operations, although the exact figures are yet to be detailed. The platform is designed to support various scenarios, including fleet routing and warehouse operations, without compromising performance. While cuOpt offers numerous benefits, there are inherent trade-offs and limitations. The long-term effectiveness of cuOpt in delivering optimal solutions remains uncertain, particularly across diverse and evolving market conditions. Potential biases inherent in LLMs may impact the quality of optimizations, highlighting the need for ongoing evaluation. Additionally, the availability of domain-specific data is crucial for successful optimization. Insufficient data may hinder performance. For those interested in exploring the potential of cuOpt, NVIDIA provides comprehensive documentation to guide the setup and operation of its GPU environments. Users are encouraged to follow the reference workflows available in NVIDIA's blogs and view demonstrations on platforms like YouTube to better understand the capabilities in a practical context. The introduction of cuOpt signifies a transformative shift in supply chain management, combining AI's power with advanced optimization techniques. As the technology continues to evolve, it holds the promise of setting new standards for operational excellence across industries, potentially leading to more dynamic and responsive supply chain solutions and democratizing access to cutting-edge optimization tools for firms of all sizes. IBM's Think 2026 conference marked a pivotal moment in the evolution of AI, focusing on the integration of agentic AI into enterprise operations. This concept extends beyond mere automation, enabling systems to operate autonomously in intricate environments, effectively revolutionizing how businesses leverage AI. At the core of this transformation is IBM's watsonx Orchestrate, an advanced tool designed to handle the orchestration of AI agents at scale. This technology promises to manage and deploy hundreds or even thousands of AI agents, each capable of individual task execution while maintaining coordinated operations. The potential here is significant. By automating repetitive tasks and complex workflows, companies can drastically reduce operational costs and improve efficiency. The IBM Sovereign Core also garnered attention, providing essential governance and compliance mechanisms. This tool is especially critical for industries like finance and healthcare, where adherence to stringent regulatory standards is mandatory. These controls ensure that AI operations align with the necessary legal frameworks, potentially reducing compliance risks. While specific efficacy metrics were not disclosed, the integration of sovereignty features is poised to fortify trust among users and regulatory bodies. Another highlight was IBM's commitment to a unified AI operating model, pushing for a more cohesive integration of data, automation, and hybrid clouds. This comprehensive approach promises to eliminate the silos that often undermine the potential of isolated AI applications, thus enhancing overall operational coherence and innovation capability. Metrics such as latency or performance specifics remain undefined, but the overarching goal is clear: foster an ecosystem where AI can dynamically interact with existing IT infrastructures. The conference emphasized trust and co-creation, particularly in regulated industries where AI's decision-making capabilities must be transparent and justifiable. IBM is advocating for collaborations that ensure AI solutions are reliable and aligned with business values. This approach not only enhances operational efficiency, but also bolsters innovation by accelerating decision-making processes and enabling faster iteration cycles. While the cost implications of these tools are yet to be defined, the potential for enhancing operational efficiency is substantial. However, challenges remain. The integration ease into pre-existing systems is largely untested, and the competitive landscape is rapidly evolving, with other tech giants like Google Cloud advancing similar AI integration strategies. In terms of practical steps, enterprises are encouraged to explore IBM's resources available on platforms like the Think 2026 event page, katie/wbm.com/events, Think, and UTM source OpenAI, and delve into the detailed AI operating model announcement. /newsroom.ibm.com/2026-0505. Think 22 Them delivers the blueprint for the AI operating model as the AI divide widens, UTM source OpenAI, for actionable insights. Ultimately, IBM's innovations unveiled at Think 2026 symbolize a shift towards more autonomous, trust-based AI systems that foster better decision-making and compliance, while encouraging technological advancement and competitive differentiation. NVIDIA's new approach, Tensor and Sequence Parallelism, TSP, is set to revolutionize the training of transformer models by significantly enhancing throughput. This strategy, developed by Zyphra, could have far-reaching implications for fields reliant on large-scale computations, such as natural language processing and machine translation. What is tensor and sequence parallelism? Tensor parallelism involves partitioning weight matrices across multiple GPUs. This technique effectively distributes computation loads, allowing weight matrices to be split along specified dimensions. This means each GPU processes a fraction of the entire model's parameters, enabling simultaneous execution. On the other hand, sequence parallelism tackles activations by dividing data along the sequence dimension. This approach helps in better resource management by distributing activation-related computations across available GPU resources. Together, these methodologies ensure that training large models is not bottlenecked by the hardware's memory resources. Technical integration and results. These parallelism strategies are integrated into NVIDIA's Transformer engine, capitalizing on frameworks like Megatron Core. Utilizing multi-GPU setups allows models to be extended to billions or even trillions of parameters, overcoming previous constraints. Zifra reports a 2.6x increase in throughput compared to traditional parallelism methods. For instance, tests have demonstrated performance gains of up to 36% for long context workloads using NVSHMEM, highlighting the potential speedups in real-world applications. Such improvements offer a compelling case for enterprises aiming to maximize computational efficiency. Practical implementation steps. Developers looking to leverage TSP can explore Zifra's documentation, which provides insights into implementing these strategies. One can experiment with existing models using demo codes from NVIDIA, potentially replicating the enhanced speeds and efficiencies internally. TSP particularly benefits those who train models with longer sequence lengths, previously limited by traditional methods. These improvements can enhance processes like layer norm, crucial for maintaining stability during training. Trade-offs and considerations. However, applying TSP is not without challenges. Integrating these methods demands higher GPU utilization. Small enterprises might find resource requirements prohibitive. Furthermore, managing communication overhead across multiple GPUs is complex, and performance gains are contingent on specific model architectures and complexities. Concluding thoughts. The introduction of TSP by Zifra as part of NVIDIA's broader efforts aligns with the growing industry demands for scalable AI solutions. As AI models continue to grow in scale, strategies like TSP will be essential in ensuring feasible training times and costs. Despite some uncertainties, such as the variability in performance across different hardware architectures and lack of wide-scale benchmarking, the potential benefits of adopting TSP could be substantial. For companies, the move towards these advanced techniques could lead not only to improvements in model efficiency, but also to cost reductions in AI development, making it a compelling consideration for future AI strategy planning. Choosing the correct AI model can significantly impact the success of an application, yet the most advanced model isn't always the right choice. Developers must understand the nuances involved in AI model selection to avoid common pitfalls such as inflated costs, latency issues, and unnecessary complexity. The misconception that the most capable systems inherently offer the best solutions leads many developers astray. Advanced AI models typically boast superior performance metrics, but these come at a substantial price. High costs are linked to increased computational demands and the need for specialized hardware, such as GPUs, to harness their full potential. For example, deploying a GPT-4 model requires powerful infrastructure that can quickly escalate operational expenses. Moreover, these sophisticated models may introduce latency, affecting user experiences negatively. For instance, while a complex model may handle nuanced language tasks, the delay it introduces might not be suitable for real-time applications like customer service chatbots. This is why Unite AI's guide emphasizes strategic model selection based on precise application requirements, rather than advanced capability alone. To create a tailored AI solution, developers should focus on various selection criteria, such as cost-effectiveness, performance relative to the task, and the practical applicability of the model's complexity to the specific challenges at hand. Internal guidelines can be developed by businesses based on pilot programs appraising the functional aspects of models in real-world environments. Additionally, using benchmarking data is crucial. It allows developers to not only compare models' theoretical capabilities, but also evaluate their performance in live settings, leading to informed decisions that align with organizational goals. Companies should prepare for potential trade-offs. High-performance models, while attractive, may not align with application needs, leading to resource waste. A lightweight, optimized model might meet performance benchmarks at a fraction of the cost and administrative burden, enabling greater agility and scalability. Those uncertain about how to proceed might explore resources like the guidelines from Unite.ai or Microsoft's AI Model Selection Guide. Practical insights and documented experiences can serve as navigational tools, offering frameworks that factor in both qualitative and quantitative aspects of deployment. Ultimately, shifting the conversation towards this nuanced understanding encourages developers to innovate within their constraints, potentially democratizing AI technology by making it more accessible and sustainable across varied sectors. This strategic approach helps mitigate risk, optimize resource allocation, and can even foster groundbreaking applications by empowering developers to choose models that precisely fit their specific needs and contexts. Thank you for tuning in to today's episode of Daily AI Brief. From Google's innovative webhook integration to IBM's forward-thinking AI strategy, we covered a myriad of developments impacting the AI landscape. Continue exploring these advancements and stay curious as you navigate the evolving world of AI technology. Join us next time for more cutting-edge insights.